not a software. It could be also something kind of interactive that plays in a very interactive way, that use some kind of library that is a more human style friendly software that you can use in order to solve and then guide you solutions in mathematics. That's something fundamental. But it's not only that they give you the solution, it also, the program also shows you. I want to prove that the prime numbers are infinitely many from prime numbers to the natural numbers. I give you the proof, I also indicate you this. We're gonna make this by contradiction. We're gonna take this hypothesis, now we take this analogy with this other concept. Now we particularize here, now we take a metaphorical thinking here, we make conceptual blending, and we are done. So that the person is quite, in a simple way, able to find a solution. There are a lot of programs and ideas and solutions in atomic theory improving, interactive theory improving, which spend a lot of time in kind of verifying proofs, if some mathematical theory is true, and trying to solve some mathematical problems. But I mean, what I see is a strong lack of human-style properties. First, in order for you to understand the syntax of the problem, you need to take a course 6 months in a very, very specific Prolog or Castle. It's quite technical. And then at the end, you get the output, and then it's a quite non-human style output, which you really need to try hard in order to understand it. And the consequence for that is a lot of people which work in pure mathematics, they don't take the time for that. Okay, no. I'm working years in algebraic geometry. This is quite abstract for me, and I need to learn a little bit of algebraic topology for my problem. And then I need to spend 6 months, 1 year in order to learn Haskell for solving the problem. Not a lot of people do that. Therefore, I want the point that I want to stress here is that our program gives step by step a human style solution. And then we have, I work in one of the biggest projects of the European Union in computational creativity. Our idea was to develop a cognitive inspired model for conceptual creation based on conceptual blending. Just using conceptual blending, what kind of things you can create. And this was a project of 3 years. There was around 15 scientists working in different universities in Europe, and then we get a very small step, but valuable stuff. We co-discovered all simple and very complex mathematical notions with the help of our system. And the people which try to apply this program to music, they were able, in a sense, to get an harmonization of a melody. So some guys say, I'm a musician, I compose this small melody. And then they ask to the program, I want to put the chords here, I want to create an harmony which is more jazz style, or is more Chopin style, or is more metal style, or rock. They try to generate some kind of harmonic solutions, such that the melody have a specific tendency. The result was quite nice. In general, for project, one of the projects was for Coinbase, and the evaluation was quite positive from the European Union. And then, in spite of for this work, I just came with the idea because we have good evidence. We discovered a lot of different notions. We have good evidence for putting a bigger project as a whole. We are able to solve mathematical problems in any level of abstraction. It's not that they give you the result of the computation, but it also indicate you how to use stuff. And in that way, you also could learn mathematics in an easier way, in a more natural way, which is not the case in a lot of people. Also, in Europe, I heard that a lot from people in Germany or in Austria that they hate mathematics. A lot of people hate mathematics because of the teacher. I know that they have experience, emotional experience, which is quite negative. It's no. And in that way, you could use a personal software, which, in a sense, explain you the stuff in a very, very easy, down-to-earth way, to get better ideas. And then, these are examples of if I can skip this. For example, a little instance of how you can use Fermat analogical reasoning mathematics. This well-known, was a quite famous problem. Fermat's theorem, that you cannot solve this equation, for exponents bigger or equal to 3, and in a non-trivial way. And some people say, an analogical is I take from this space. What happens if I change natural by polynomials with complex coefficients? And some people say, good, maybe this is true also. and then some people were able to prove, after having this analytical enlightenment. Yeah, we also, with some colleagues, we're also trying to develop, some simple analogical reasoning. If you have these two, I show you these two propositions, propositional logic, these two sentences. You say, what is common there? You say, because P implies, and here they are different. Put I put a label here, a syntactical label. We develop a kind of, we are trying to develop automated theorem prover in propositional logic, based on just analogical reasoning. And we are doing quite well. A lot of arguments, which in classic books of logic, they say this is a quite out of the blue argument. Using this small step combination of this analogical reason, we can deduce this out of the blue, which is to say, we just try an error, we try a lot of cases, and then we get the idea. But then now we say, no, maybe this out of the blue is just an analogical thing. And we are also working on that. As I told you, with Stefan Hensel, I'm working this concept of subtractum. You can think, for example, here, even numbers. This could be the subtractum, the essence of an even number. Multiples of A, A times something, with something the integer, the essence of that. Composite numbers, a composite number, you can express it as a multiplication of two numbers, which are strictly bigger than. If I were to put, in a sense, 2 here, then it's strictly bigger than 1. In the sense, you have some perfect numbers, and even for prime numbers, if you use more technical stuff, some guy gives that's a prime number. These are exactly the prime numbers. If you put n here, n, and you complete this formula, it gives you explicitly of the prime numbers. Then one can see that could be a way of understanding the prime numbers explicitly in your what screenshot. Yeah, that's the prime number. That's the essence of the prime number. Yeah, and then we are working on that in also. Working in CoinBen, as I told you, we were able to co-create this notion, which was a little technical notion in computer algebra. We call this notion containment division ring, and then I was aware that this notion was discovered by Crew in the 20s, but in a very, very specific, in a quite sophisticated way. He also co-discovered this notion. But we using our software, the people from CoinBen, and using the people from CoinBen, and using this HEADS software, which is a software which is able to compute blending of mathematical theories. You can put here a concept, you give actions in something like many sort of disorder logic. You put another axiomatization. You put how are you going to identify the symbols here, and the software creates you the combination. We'll show you later a little bit about that. With this software, we're able to find this, this notion, to co-discover this notion, in a very, in a very easy way, without working with very years of commutative algebra to thousands of examples. No, we just discover this in a very straightforward way, with the help of the software. And now, using that, we're able to prove some kind of nice equivalences between a very well-known notion. It's quite technical. Maybe the notion of containment division ring was a ring in which the ideals are like the substructures of the ring, fulfill some kind of natural notion which say if one ideal is containing another ideal, if and only if this ideal is a multiple of the other one. Or even if and only if this ideal J divides I. This is continuous even only if it happens, divide the other one. It means this. That I could be written like J times H, where this is the multiplication by B. That's a little technical stuff. The main fact that was using this system, we were able to find quite fast solutions, or even to come up with a notion, this kind of notion. Good, and now this is the introduction of what I call you how we understand concepts. We fix a language, and we also fix a kind of sorts. You can understand we have sorts and variables, and one can also say for all, a typical example would be for all number n in the natural numbers, there exists some number c into the integers such that n plus c is equal to 0. That means any natural number has an inverse in the integer. For that, you use sorts. for any variable of these sorts, there is some other variable of other sort, such that something happens. We use this kind of framework. And then for that, we modulate, I mean, this is quite technical. For this, we modulate the notion of colimit here. The notion of what I call the blend. I have this one concept. Yeah? This concept have some syntax, some symbols, some language we use it, some specific actions, and have some models. All this structure will fulfill the concept. For example, if I, as one example, thinking dogs in English, what would be the concept as such? The concept would be a collection of all the properties, the biological properties that a dog should fulfill, written in English, with English letters. Would be. What is the language? The letters of the English language, and the alphabet that we have, the normal one. We have this finite collection of actions, biologically inspired actions of DNA or something like that. This is a dog. And then you take the collection of all the models for that. What is that in the case of dogs? All the dogs in the world. In the concept of dog, you put all the dogs that exist in this moment in the world. And you put all the properties that characterize what a dog is. You know, we have kind of intuitive idea of what is happening. Then if you have two concepts, then you can also define amorphism between concepts. You could send a concept, for example, the concept of dog, I send you as an embedding to the concept of animal. The concept of animal is a brighter concept. Therefore, we can see the concept of dog as sub-concept, the concept of an animal in general. Then we translate this in mathematical terms to mathematical axiomatization with some technical stuff. And then what is nice is this in this category, this is a category, category is a particular mathematical structure, which is so nice that you can compute some kind of colimits. This is a mathematical notion. And the colimit mainly is, for example, the Cartesian product of two rings. You take order pairs, R1 times R2, you take order pairs, and you define component-wise the operations, and then you have a new structure. Yeah. Then the next step that with notion of colimit, we modulate. We say the blending. You know, we say the blending of these two concepts. When we identify these two concepts by using this concept G, in this concept G, what we want to codify is what kind of symbols in the language are you going to identify with the elements here. Let's say if I take G for dogs and A for animal, then I want to identify in my combination, I want to make a blending of these two concepts. I want to identify these sort dogs D with a sort A for animals in some new sort, which I call it W. And then the colimit of these two would be the blending, the combination. This mathematical specification, which is called colimit, would be exactly the blending of these two of them. And then with that, we were able to do a lot of stuff. There was a kind of magic there. Like in this Queen, you can a lot of concepts start to be created. There's a kind of magic. You have, for example, ideas and meta primes, you get prime ideas. You combine these prime ideas with meta primes, you get prime ideas, and then you combine, for example, the Taylor rings and containment division rings, and then you get a new ideal different domain. Or you can combine another way. You get containment division rings, and you say rings with this kind of divisor containment condition. You put a trivial identification, and you get another concept. And we were able not only to create concept in a 2 or 3 concepts, but we were able to, by using very simple concepts, we were able to create whole theories. With this, for example, these are the basic concepts we create with these two notions. We create this notion of a group, and then with this, we combine it with the notion of distributive space, and we create field, and then after that, we were able, these 4 notions, and then one of them was the most fundamental notion of Galois theory. We were able to create these 4 notions with these 5 ones, which belongs to different kinds of mathematical fields, all of them. And then by doing kind of this blending, going upwards is doing blending. I blend these 2 times, and then I get this notion. I blend this notion here with this notion here, and I get this notion. I blend these two notions, and then I get this. Then with these 5 belonging to different fields, we were able to create one of the most fundamental notion of physical Galois theory, and type theories, in a very different way. In a very, very different way. I mean, this is not the way at all as which the researchers at the beginning of Galois discovered the stuff. It's quite different. And in a sense, faster than the classical way of doing mathematics. It's a different way. And yeah, what I want to show you here, that's the way in which a Castle, this HEADS program, describe, the actions. You have the sort, you specify here the sort, the symbols, and you put here the action. Although it could happen that someone does not know so much about computer science, it could also in a very easy way to understand what here is described. You put here for all, what people would say, the universal quantifier. For all x, an element in this sort, and for all y, element in this sort, x plus y is y plus x. It's commutativity. This is a very user-friendly oriented software. We use this kind of software to understand what was happening. This is the way in which we specify the stuff. You define the specific generic space. You define also the morphisms. You say this sort goes to this sort, this element to this element, and after that you define this command combine. This combine computes equilibrium, and then after that you get a huge exponentiation of what do you want. For this concept, we do all the implementation in Castle of computer skills. Now, work in progress is exactly the same for Lie proofs, which is a very different field of mathematics. In a sense, we're starting with these notions, we're trying to, conceptually, to factoring. In which way a complex concept could be factored. If you think a little bit like Blender is like doing product of concepts, then in which way I can take a concept and I can find the factorization of this concept into different concepts. And then, we use, blending. In our process, we use programs like Prolog for one of this blending software. We use HEADS in the Castle language to build some parts of COBOL. We use Python to this analytical software, which is something in progress. And what we see now is we're trying to see what would be the most suitable, the most general, the most powerful language in order to construct the whole AMI program. Either we start from scratch from the beginning, try to develop all the tools. One can use this Wolfram language, which is quite strongly mathematically oriented, but it's also a big question. We are now taking the foundations, the initial foundation, and after we are forward or in a model when we have more advanced results at the end, we care more carefully about that. And then finally, this is the the size of this project is huge. It's the whole mathematical spectrum problem. Therefore, we are building a community worldwide of different scientists in which we want to get people in touch with just support the project intellectually. We want to have some ideas. We want to be friends of the project. We have some kind of specific research in different areas of mathematics and also computer science, which can support intellectually the project, be part of it. Because I want to put this project, as you know, in general, it's difficult to get only funds for the universities, or the institutional research entities, and I want to get fundraising privately, in general, for the project, in order to create a kind of institution which is independent, because the scope of this project goes beyond mathematics. Of course, if you are able to create this kind of software, then everyone working in chemistry, people working in theoretical computer science, theoretical physics, in a company, they could reduce their problems to mathematical problems. I have this mathematical problem, but I don't have the time to do the training in mathematics. I don't have 1 year in order to learn partial differential equations. Good, I get the software. Then the software explains me the solution. Then I can publish a work which is more mathematically oriented, more structured, with a strong mathematical background. Therefore, I want to invite you, if you want to visit the sites and the construction, starting that. And at the end of this one, we start one fundraising campaign in general. And then you can support the project in very different ways. But the first step that you get really involved, get passionate about it, you start to believe in that, and then in different ways you can support the idea. So thank you very much.
Okay, think we might have time for one or two questions. Someone?
Very interesting. Good luck. Something I was imagining at the beginning of your title was just about to talk about the deep learning and artificial intelligence, all these new topics, common topics now, hot topics. That's the word. But something that is very difficult in this new, well, in this new world, because the approach is very old, is that it's very difficult to explain what is happening inside this neural network that they usually. I guess you are not used to this.
No, as a structural.
It's not possible to explain because you want the way to explain how you get to this result. And if there is any compatibility between these two ways to do things, because here you have a prolonged way to do things, and on the other side you have these huge data-driven methods that use neural networks. I wonder if somebody has tried to, using your formalism, try to have so many theorems written in formal language that can be given to a neural network, and something happens. It happened there because it's difficult to
The people that have a quite global vision of the project, step by step, I know how to maybe to match that. What I see a little bit injury is that you formalize something, you put it in the black box, and then you do something good. But at some point, you lost a lot of time trying to grip inside the black box in order to see why it happened. I want always in each step of the project to keep control, structural control. These are the cognitive abilities. They have not seen, in no way that someone is trying to classify all the structural cognitive abilities. The people, for example, on analytical thinking, they say everything is an analogy. It's a little bit strong claim. The people from cognitive linguistics, they say everything what you think in your mind in your life is metaphorical reasoning, and they try to to build models with just the metaphorical thing. They're saying, no, it's too strong for me. Sometimes you can use conceptual blending and you get faster in a more natural way because we combine ideas. We're always translating ideas, but sometimes we are combining ideas. Therefore, in this sense, I want to keep the control available to explain. That's what I want to offer, as a contribution. And maybe because it started the project in huge, the amount of work that it could require is a lot. That I classified it. Even a neural network with deep learning, it spend years. And at the end, give me something nice, which is small, another concept. And then I need to spend 3 years in order to understand how this huge stuff happened. Because if someone from deep learning say that's amazing, therefore I take friends of the project, So which is an expert. Good, Danny, give me 20 concepts of your project in your Castle language, and I put it there and analyze stuff. That'd be great, And I found this Danny, and we can work together. But he has the ability, the capability, the system for that. Very good point.
Speaking of that, so if I understood correctly, you're working in a very interesting way in analyzing math. So you have all of these theorems, and each field will claim that they're doing their stuff on their own way, and the center of the universe, and so on and so forth. But if I understood correctly, basically what you're trying to create is like a language that not only explains the different steps, but also the transitions. So you define okay, I apply metaphorical whatever here, an analogy here, and blah, blah, blah. So in that sense, you could write every single theorem and its demonstration in this language. So, So that means that what you could feed these systems are those steps. And then somehow, supposing that is possible, you could produce another set of steps that it's in your language. So it's not really you will be needing to really understand how it got there. I think that would be kind of the job of the person that is an expert on that. But what I'm trying to say is that if you have enough examples of all of these steps in a very well-defined way, it seems to me like it should be able to also generate other examples in that same way. And then we follow up, actually go a little bit step further. So one of the things that I see you're trying to claim in there is that you want to create something that people can actually understand. So do you have any plans in that? Because I saw the language, but I didn't really see much difference from that to Haskell or what you were saying.
I don't know. This is just a quite initial stuff. There is also a whole program. This is a heterogeneous tool set which is developed by Musakowski. But I haven't planned to create a new kind of explicit notation. It is just to show you that of all the different languages that exist, there are ones that are more friendly. So there are other ones, but I don't want to take exactly this kind of.
So what is your strategy for explaining the results of what your system produces to the normal human?
That would be a kind of the system will have an internal transition property. You put a user in a very normal way, in the way in which you specify concepts, for example. Internally, the system will put it in an explicit way, which is quite technical, and I am developing a quite huge stuff, which is heavy, but have more information. You have in a way all the information that you won't have. It starts to do, and in each of the steps, it made the translation to put you here, is conceptual blending. But you want to understand with the technical explicit language.
No, but what I'm saying is like, so at the end, you will put it back in English or something like that, or
exactly, yeah.
But even if you do that, like every time I go and I read a demonstration and looking at your slides, I still couldn't figure out what the heck was that talking about. So if I don't have the fundamentals in math, reading like English, explain.
Because the example that I show is just to give two concepts to combine them.
Okay.
But I'm not, in this example, I don't show how to proceed with a proof. Okay. I'm now doing prototypes, and one of the biggest steps where I'm taking inspiration was my PhD thesis, because I proved around more than 30 theorems in different small theorems. And then I get an idea of, in each of the theorems, I use this and this and this and this, and I go to meta-formalize this thesis as the initial, because I know how to get the ideas of the thesis. And it was ideas of different people, because for me, with the help of two advisors, I make a kind of sandwich PhD, which you have two advisors, one in Germany, a kind of blending. Then I get each of the two doctoral files were different in the ways of thinking. Quite different. One was more example-oriented, the other one was more structural and general definition. But in each of them give me different kind of aspects of how to create ideas. Therefore, the first case study would be with my PhD, and then I really.
Okay, let's.
With your last slide, you showed to get to lightbooks with other technical fields. Will this be able to prove new things? Like this way, like you showed, you go to the Galois theory from different geometric fields, like miracles and everything. So this kind of approach could provide with some proof to not resolve problems.
Yeah. That is maybe exceptional.
Yeah. So do you plan to launch campaign to find some new proof, like I don't know, the zero Riemann function?
Yeah, in this sense, yes. There could be a kind of universal mathematical problem solver. That's the main, the main idea. Yeah. But also new stuff. Thank you very much.
Well, let's thank our speaker again.
Thank you.
Okay, so let's continue with our second presentation of the day. So I leave you with Nicole, she's going to be explaining the news.
Lo que quieras.
Lo que quieres.
Hola, buenas tardes. Bueno, mi nombre es Nicole y pues el día de hoy les voy a hablar respecto a mi tema de tesis. Estamos trabajando pues, en la parte de testing, orientado hacia la parte de visualizaciones y sistemas interactivos en general. Entonces, ¿qué va hasta ahora? Pues iniciando, como siempre, uno empieza como a buscar, bueno, qué existe, qué no existe, qué han hecho, qué hay en el campo. Lo que encontré es que hay muchísimas cosas, no hay algo como tal dentro del campo que nosotros buscamos, o sea, no hay una preocupación real por, o puede que la haya, pero no la han explotado, por testear las visualizaciones. Hay testing de muchos tipos, uno puede encontrar cantidad de surveys, pero son surveys muy acotados, entonces son surveys que se enfocan en un tipo particular de testing, entonces testing que está orientado a performance o en software testing, pero digamos que desglosan en 3 niveles de abstracción básicos. Y si yo quisiera saber, el primer problema que tuve fue, bueno, si yo quiero saber qué es todo lo que existe, ¿cómo hago? Y no hay un survey como completo, que me dé un overview completo de todo lo que hay. Entonces, lo primero que hicimos fue plantear una taxonomía a raíz de eso. Esta taxonomía es una locura en el sentido de que uno puede encontrar una diversidad de definiciones. Para un autor puede ser una clasificación de X estilo, para otro puede ser las mismas cosas, o sea, los mismos tipos de testing, pueden clasificar de otra forma, o pueden ser subtipos de otra cosa, o son equivalentes que reciben otro nombre. Entonces, pues fue un poco loco, pero pues a eso se llegó. La parte que más me interesa a mí es esta parte, que es la parte más pequeña, que es la parte de testing para interfaz gráfica. Entonces, en esta parte yo identifiqué como 3 ideales a probar, aunque no se ven muy bien, pero la parte del comportamiento, la interacción, y como tal, del versionamiento. Entonces, del comportamiento, pues es algo que realmente se prueba en casi que todo testing, buscar que el comportamiento sea el adecuado, el que uno desarrolló. Entonces encontramos que incorporan model-based testing e incorporan manual-based testing, que pues, es el menos ideal y asombrosamente es con el que caemos las personas que estén desarrollando visualizaciones. Porque usted prueba, cambia, así como que no se me dañó nada, ya mejoró. Entonces, lamentablemente caemos en este. Este también busca apuntar hacia parte de las interacciones, porque uno manualmente llega y espicha una cosa, prueba otra, cambia y pues prueba las interacciones que tiene. Por otro lado está la parte de versionamiento. Entonces, este no solamente aplica acá, sino que aquí también ustedes van a encontrar algo que se llama regression testing, pero se inventaron uno en particular que es el visual regression testing. Entonces, ¿qué pasa? Yo soy desarrollador web, hice mi app muy bonita, ya está estable, sale, hago un cambio y me tiro todos los estilos, o descuadro el banner, o me tiro todo. ¿Y cómo garantizo yo que es la forma de ver eso? Porque como no puedo tirar algo muy notorio, puede ser algo muy pequeño, que se dé cuenta el usuario que ya está súper habituado a la interfaz. Entonces, ¿cómo me doy cuenta de eso? Nace Visual Regression Testing. Entonces, este le apunta como al versionamiento y también como a las interacciones. Este tipo de testing se da con ciertas herramientas en particular. O sea, ahorita les voy a hablar como muy por encima qué tipos de herramientas nacen para el testing, o sea, hay diversidad de herramientas, pero pues como que tienen unas características enfocadas a ciertas necesidades y al objetivo del testing. ¿Y qué pasa con visualization testing? O sea, si yo quiero probar mis visualizaciones, ¿en dónde caigo? Manualmente, pues no debería, pero no hay un visual regression testing como tal que se enfoque hacia las visualizaciones. Y porque las visualizaciones son especiales con respecto a cualquier página web que yo conozca. Entonces, bueno, por el lado, ya les voy a contestar la pregunta, pero por el lado de las herramientas, podemos encontrar, sí, suspenso, por el lado de las herramientas yo puedo encontrar muchísimas herramientas que caen en esta categoría, que es Record and Playback. Entonces, el usuario prácticamente lo que hace, pues el tester lo que hace es que prácticamente puede grabar como ciertos escenarios y puede volver a reproducir una y otra vez, puede hacer el playback de esas cosas y puede, la idea es que pueda encontrar si hay diferencias o no. Lo que es Visual Regression Testing básicamente cae acá. Entonces el Record and Playback puede ser a punta de hacerse como tal, pero también pues hay herramientas que utilizan reconocimiento de imágenes y para cosas más. Como tal, la automatización de test, entonces pues estas cosas se unen, o sea, esto no es como que sea una clasificación ajena a los demás, sino que son mezclas que se dan entre ellos. Hay herramientas que buscan es verificar el cubrimiento del código, entonces pues se enfocan en eso, en verificar cuánto código ha sido cubierto con respecto a la cantidad de test que hay otras de performance, y pues hay muchísimas dependiendo de la perspectiva, vuelve y cae, dependiendo del autor, dependiendo de las necesidades de clasificación. Estas son las más importantes, las más interesantes para mí. Entonces, ¿qué pasa? Nosotros ya sé que básicamente hay un montón de cosas, pero no hay algo como tal que responda a la necesidad. ¿Por qué? Porque lo que yo puedo hacer en ese momento es, con Visual Regression Testing, como les decía, ellos pueden utilizar otras formas que es tomar imágenes. Entonces toman screenshots del comportamiento que hay en el momento, una vez yo saqué una versión estable de mi código. Entonces, bueno, es esta. Y esa yo la utilizo para hacer un baseline con el cual voy a comparar una vez yo saque otra versión. Entonces sé si hubo un cambio no deseado o un cambio deseado, porque pues obviamente a veces uno busca que hayan diferencias. Entonces, este tipo de cosas se hace por interacción de usuario. Entonces, pues hasta ahí vamos más o menos bien, porque pues me dice, bueno, yo sé más o menos qué tipo de interacciones le estoy ofreciendo a la persona que va a utilizar la página. Me permite comparar como tamaños, posiciones de ciertos elementos, entonces que el div no haya cambiado de lugar, que el tag X tag esté donde debe estar, que las imágenes, los botones, que todo esté donde yo espero que esté. Y pues por otro lado también obviamente han avanzado no solamente en la parte web, sino también en la parte móvil, entonces uno encuentra también que hay herramientas que se han ido desarrollando enfocadas a esta parte, al testing de esa parte. Pero ¿qué pasa? ¿Cuáles son las desventajas? ¿Qué es lo que yo todavía no he encontrado y que me hace falta o que me puede hacer falta? Ya les digo también. Entonces, las transiciones y las animaciones son ruido. Entonces, básicamente, a veces uno quiere saber cómo le fue con las animaciones porque es lo bonito y lo que no. Entonces, para que no sea como súper agresivo el cambio para el usuario de una gráfica a otra, para que no sea como que se pierda la apreciación incluso de un detalle, de la descomposición de un detalle, que la persona entienda que, esto descompone tal, entonces este tipo de conceptos componen eso. Por ejemplo, si yo quito esas transiciones, a veces es demasiado ruido que la gente pierde detalles, entonces no siempre una transición es ruido. Para la gente de Visual Regression Testing, como es un dolor de cabeza tener animaciones, que ven un gipsito ahí moviéndose, ellos prácticamente congelan eso, para ellos eso no tiene valor, entonces es ruido. Por otra parte, pues las interacciones son tomadas de elementos básicos, y por ejemplo, dependiendo en qué se esté trabajando, dónde se esté moviendo mayormente el desarrollo de visualizaciones, los elementos no son tan básicos. Hay tags especiales, hay círculos, hay barras, hay cantidad de palabras, hay cantidad de código que sería como que le facilitaría la vida al desarrollador o al tester que estuviera incluido dentro del diccionario, dentro del mundo de su librería para hacer testing, que no fuera algo tan ajeno y que le tocara ir buscando clase por clase. Bueno, la clase entity se llama Circle, listo, ahí voy a modificar y voy a poner esto. Por otra parte, pues, no hay una solución suficientemente cercana para simulaciones. Entonces, ¿qué pasa? Pasa que, si bien yo no estaba hablando de simulaciones, ¿por qué las incorporo acá? O sea, yo no he encontrado un testing como tal efectivo para simulaciones. Pasa que yo tengo visualizaciones en tiempo real. Entonces, eso también va a ser un problema si uno está probando, porque no es solo una animación, realmente es que hay visualizaciones que se mueven a lo largo del tiempo y ese es su fundamento, mostrar datos que están cambiando. Entonces, ¿cómo voy yo a congelar esos datos? Porque es un ruido, porque son animaciones. Entonces, tampoco hay o sea, como dentro de los lags que hay actualmente en testing, se encuentra eso, que no hay como algo que me brinde un respaldo para las cosas de simulación. Entonces, bueno, eso por un lado. Pero ¿cómo hago yo para saber? Porque, pues, yo puedo parar y decirme, no. Para mí lo más importante es que no haya overlapping cuando yo estoy desarrollando, porque entonces se me cruzan los textos y no entiendo. Pero pues yo no soy la única persona, ni soy la más dura en el área. Entonces, ¿cómo sé yo qué es lo que es interesante realmente cuando uno está haciendo? Entonces, la idea es correr una pequeña como encuesta, así como difamarla por Twitter, punta de hashtags, para que la gente que está en el campo me diga datos que me sean importantes, como qué utilizo actualmente para desarrollar. Eso también puede marcar el camino de lo que yo vaya a hacer. ¿Qué tipo de cosas le gustaría probar? ¿Y cuáles son el tipo de cosas que le dan dolor de cabeza siempre? Usted llega y prueba, ya me voy a tirar esto y ya lo voy a arreglar. Y pues que si utiliza una técnica en particular, si es muy artesanal o si de pronto hay gente que ya se inventó un pedacito de algo por ahorrarse el dolor de cabeza de alguna cosa. Esa información es valiosa para mí. Entonces, ¿qué viene? Básicamente, pues en este momento la idea es, estoy haciendo experimentos con las herramientas actuales, hasta donde me dejan llegar esas herramientas. En este caso, BastofGS, que es una combinación de 3 herramientas, de 3 tecnologías, que permiten modificar el DOM, hacer el testing, o sea, el hacer, y me permite tomar screenshots y hacer comparaciones con respecto a esos screenshots. Entonces, primero, pues conocer muy bien y ver si realmente eso me permite hacer todo lo que en teoría debería. Definir algunas visualizaciones básicas, hacer experimentos ya teniendo en cuenta esto, para tratar de hacer testing sobre marcas y canales que me interesen. Si realmente con el mismo set de datos que yo estoy corriendo no se me está desapareciendo una barra después de haber actualizado el código porque resulta que se hizo un sort que se le está borrando un dato y no se dio cuenta. Si realmente hay overlapping o no, esto va a depender mucho de los resultados de la encuesta, porque pues depende de lo que le importe más a la gente que se mueve en el campo de las visualizaciones. Y cuarto sería tomar varios baseline para diferentes resoluciones, porque pues todo se está moviendo, incluso si hay parte móvil, toda la información se está dispersando en diferentes dispositivos, y pues es como un poco inocente a mi parte pensar que solamente van a testear en el computador que es igual a mi computador. Entonces sería hacer como un conjunto de baseline para poder garantizar que sea que se cubre una participación de eso. Y ya. Entonces, gracias.
¿Preguntas?
Bueno,
es un comentario respecto a la taxonomía de pruebas que dice que las otras seguras. Hay muchas, y hay una súper importante que es la del software engineering explicación. Entonces incluye pruebas para o sea, es súper completa. Incluye todos las que puedes, incluye un montón de pruebas que han recopilado varias en Carnegie Mellon desde hace mucho tiempo, y las pruebas que ellos hacen con todas las sociedades gubernamentales y militares. Entonces se busca software engineering institute testing taxonomy que encuentra. Hay charlas, hay papers publicados al respecto, explicando cada una de las pruebas. Porque puede que yo voy a hacer encima y pues hicieron falta de tiempo.
Sí, no, esa taxonomía no está totalmente económica. Es bastante.
Pero también de vos la que no va a dejar una de los que se pueden hacer falta cosas.
Vale, muchas gracias. Muchas gracias.
Te iba a preguntar respecto al impacto del tamaño del browser, pero ya al final dijiste que iban a sacar bien los dos screenshots de diferentes resoluciones locales y después para comparar. Hay muchas cuáles son las resoluciones que se toman como referencia.
Exacto.
Porque digamos que en algunos dispositivos el paso responsive o no responsive para filtrar ciertas cosas o no, pues depende. Entonces tener que hacer una prueba de ensayo de error o para ver en qué resolución sí hay un impacto en la visualización o no, o hay un impacto en el layout de la página que puede hacer el cambio. Porque entrar con screenshot es una manera porque es súper sensible al cambio. Y por el cambiecito puede cambiar de un punto de vista a otro. O no sé cómo hacer la comparación. Y la última, perdón, tú decías que vas a mandar preguntas por Twitter y eso.
Sí, pues es la idea.
¿Y cómo van a hacer el análisis cualitativo?
Pues es un formulario, entonces pues obviamente busco dar como opciones de lo que yo creo para también ponderar y obviamente dejar lo otro. Pero si no voy a dejar tan abiertas las preguntas, si no me vuelvo loca. Entonces,
se requiere métodos de open coding o random theory, cosas así.
Vale, muchas gracias.
Yo tenía varias preguntas. Lo que tú buscas es hacer una librería que combine lo que ya hacen otras o que combine lo que hacen otras y además agregarle lo que la gente reportó en Twitter como un problema actual.
Vale, pues la idea sí obviamente en un punto es hacer una librería, en este caso sería como un prototipo, pero pues en algún caso sería una librería, y es brindar con base como a las tecnologías actuales una capa adicional para poder cubrir las falencias dentro del testing de visualizaciones.
Y la otra era cómo determinabas, dadas las encuestas que estás haciendo, qué soluciones le ibas a dar a qué problemas. O sea, ahí me imagino que te van a surgir como 1.000.000 de problemas respecto a testing de visualización. Entonces, ¿tú cómo vas a determinar qué vas a abordar y qué no?
Vale, pues, bueno, dentro de esa parte, pues obviamente como que uno entra a jugar. Ahí sí tiene que tener un criterio personal, pues uno no puede como satisfacer las necesidades de todo el mundo. Y pues entrar a jugar con las cosas que se clasifican como más impactantes en una visualización, digamos, marcas y pues los canales que sean como más predominantes, las marcas que sean más predominantes y más importantes. Entonces, pues como que empezar a priorizar también en orden de lo que la teoría de la visualización también nos sugiere, pues establece.
Ahí también tendrás en cuenta, digamos, no sé, que se está visualizando 18 barras, que en la versión móvil pues vas a tener que scroll 1000 veces también, cómo se maneja eso.
Eso digamos que es algo que me toca explorar cuando llegue a la parte de la resolución.
Una última conclusión.
Sí.
No sé cómo piensas hacer las pruebas, pero de pronto resaltaba algo que decía Mario, es que hacerlas en el raster final o en la imagen final puede que sea muy bajo nivel, porque pueden haber muchos cambios que no tienen nada que ver con la información. Entonces, no sé, y por otro lado, se utilizan librerías de empresa o que sea. No sé qué tanta información tienen o de las aplicaciones o de los cambios que quieres también probar para que tú puedas poner con un nivel intermedio y no comparar imágenes. Una imagen suena muy complicado. No sé qué has pensado al respecto.
Pues igual como también jugar con la parte de manipulación del DOM, porque pues igual tienes como, tú eres consciente de que el entorno te va a dar cierta respuesta, entonces también puedes jugar por esa parte, como de modificar por debajo por el DOM o activar un evento, y hay cosas que determinadamente de pronto se pueden exactamente, para no darse tampoco todo mandarlo a la imagen o todo mandarlo al DOM, sino de pronto buscar un equilibrio.
Muchas gracias a todos. Nos vemos el próximo lunes. Para los que van a exponer en siguientes versiones, me parece algo chévere lo que presentaron ahorita, que la presentación está en inglés, aunque ustedes presenten en español, pues damos el espacio para que alguien entienda de qué estamos hablando. Bueno, gracias. Yo tengo que correr, tengo otra reunión. Vamos a por ellos. Muchas gracias. Salgo corriendo. El virtual o sí, no, definitivamente lo que decía Nicolás al final, uno de los problemas es cuando uno trabaja con Canvas, que con Canvas se pierde completamente la. Entonces, definitivamente, o sea, una de las cosas que queremos hacer al principio es, que es lo que dijo Nicole, es hasta dónde nos llevan las herramientas actuales. Y ahí es fundamental, yo es porque no tenía idea que te hacías, pero entonces ahí es fundamental que tú nos cuentes, porque nosotros, por ejemplo, tampoco ni idea.
Chao.